Assalamualaikum warahmatullahi wabarakatuh. Today we want to present our group assignment, Integrated Sustainable Solution for Water Pollution. This is our group members, Muhammad Fakri Riza bin Muhammad Asmadi, Muhammad Syafiq Fitrisyah bin Muhammad Fauzi, Muhammad Rehan Zihni bin Mak Syarul Mauludin, and Cik Engko Akif Ayash bin Cik Engko Ridwan. So our case study for this assignment is water pollution caused by landfill site Trash Mountain at Delhi, India.
At the eastern edge of New Delhi stands a mountain, not of rock, but of waste. For decades, the Gazipur landfill has grown silently, absorbing thousands of tons of garbage every day. What rises above the city is visible to all, but what flows beneath is far more dangerous. When rain falls on the landfill, it does not remain clean. As water passes through layers of decomposing waste, it forms a toxic liquid known as leachate, a complex mixture of organic pollutants, heavy metals, and dissolved salts. In engineered landfill, leachate is collected and treated, but Gazipur was never designed to hold waste for this long, or this much. Recent inspections and environmental monitoring between 2020 and 2025 revealed a serious reality. Leachate from the Gazipur landfill has been observed flowing into nearby drains and percolating into the ground. Groundwater samples collected around the landfill show elevated levels of total dissolved solids, chloride, hardness, and other contaminants, many exceeding safe limits for drinking water. This contamination threatens not only underground aquifers but also surface water systems that ultimately connect to the Yamuna River. For communities living around Gazipur, groundwater is not an abstract concept. It is a daily necessity. Polluted water affects household use, sanitation, agriculture, and even food safety. When contaminants enter the soil and water, they do not disappear. They accumulate, moving silently through ecosystem and human lives. India National Green Tribunal has repeatedly flagged the Gazipur landfill as a major environmental risk. Despite mitigation efforts, inspections continue to report leachate and leakage and incomplete containment system. The crisis is not sudden. It is the result of prolonged inaction and delayed remediation. This case study examines Gazipur landfill as more than a waste management failure. It is a warning of how unmanaged landfill Gazipur can become long-term sources of water pollution. To understand the future of urban sustainability, we must first confront what lies beneath our waste.
Analysis of causes and impact. So the physical causes of pollution is leachate seepage. What is leachate? Leachate is the liquid materials that are drained from stockpile material or land. Leachate forms when rainwater passes through layers of mixed waste. What makes leachate so dangerous? Because it has the most hazardous products, which consisting of four major types of constituent, which is soluble organic matters, inorganic component, heavy metals, and xenobiotic organic compound. India have very lack of effective leachate collection system. That's why leachate can seep directly into soil and groundwater. Chemical causes of pollution. So the chemical cause of pollution is the releasing of dangerous toxins in groundwater. So the dangerous pollutants have been seeping into the earth that can contaminating the water supply for local residents. The groundwater within at least 500 meter radius around the waste site is contaminated. Ammonia and sulfate levels were much higher than the acceptable limits that are set by an Indian government. Levels of total dissolved solid, known as TDS, which is the amount of the organic materials and inorganic salts dissolved in the water, that were nearly 19 times the allowed amount, making it unsafe for human consumption. In India, 500 mg per liter is considered good by World Health Organization, but anything above 1,200 mg per liter is unacceptable. Experts found that TDS level at this landfill in between 3,000 to 4,000 mg per liter, Can you imagine? It is way off the acceptable limit. Not just you cannot drink the water, but you cannot take a bath, even wash your clothes or dishes. That shows how much polluted the water become. So the environmental, social, economic and health implication. For the environmental, we have water pollution, soil degradation, which is the loss of soil quality, and loss in biodiversity, which is the disappearance of plant animal species that keep ecosystem balance. And then we have social, which is the limited the access to the clean water and dirty surroundings. For the economic, the government need to spend heavily on water treatment, healthcare and landfill management. For health implication, we have disease such as increased spread of waterborne illness like cholera or respiratory issues. And then vulnerable group, because high risk group like children, the elderly and the pregnant women are often the first to suffer because the immune system are more sensitive.
Based on the problem that happens in Garbage Mountain, Delhi, India, we have some solutions. So we have three types of solutions to solve this kind of problem. So first we go for natural treatment. Here we have bioremediation. Bioremediation is a biological treatment which is we use microorganism to consume harmful substance. So from here we can clean up contaminated groundwater like heavy metals. So we can reuse this groundwater again as a fresh water as we take out the pollutant from this groundwater. This method is not really costly compared to the other treatment. Next, we go for another natural treatment, which is anaerobic digestion. So this method is a process where microorganisms break down organic waste into several substances. From here, we can produce few substances, and one of them is a nutrient-rich solids. As we know that the plants need nutrient to grow, so we use this nutrient as a fertilizer for plants to grow well. Therefore, these plants would contribute an oxygen to the human and other life. And of course, this method offering sustainable waste management and energy generation.
So, providing the integrated solutions for this leachate management, mitigation, from the engineering perspective, we could use the landfill gas capture and utilization, which is LFG recovery. So, which use a method by using the captured methane-rich gas to evaporate the said leachate, reducing its volume for easier treatment and disposal. So, how does it work? The landfill gas, mainly methane and carbon dioxide from the organic waste decomposition, it gets collected by the extraction wells and pipes under the vacuum. So the gas power the evaporator or boiler that will heat the leachate and turning the water content into a vapor while concentrating the pollutants for the processing. So this cuts leachate volume by up to a certain percentage in some systems, lowering the disposal cost and avoid the fossil fuel use. So for the mitigation benefits, the evaporation prevent leachate accumulation, which can otherwise contaminate groundwater or overload treatment plants. Capturing LFG also curbs methane emission, a potent greenhouse gas, turning waste into energy like electricity or heat. So efficient drainage alongside gas system blocks leachate entry into pipes, enhancing the safety. So we could also, while mitigate the problem, the leachate issue from affecting environment, we could also turn it into another source of energy. For the integrated solution under the policy and regulation, so under the India Solid Waste Management Rule of 2016, landfill must now collect and treat harmful leachate before it pollutes the groundwater, foreseeing the smarter tech investment that protect their health and environment from toxic leaks. So it requires the operator or the company or parties to treat leachate to meet the CPCB discharge, which is the Central Pollution Control Board standards that prevent the groundwater for pollution from the toxin, from polluting the environment. So the implication of not following the standard or rules will be fined by a daily penalty or jail time up to 1.5 to 6 years, or being penalty up to 10 lakhs, or converted in Malaysian ringgit around 5,000 or can be higher. So this policy drive cleaner tech adoption and protect the community from pollution risks by implicating a consequence for not following the said regulations.